Greetings everybody, and today we're going to be taking a look at question 3 of the 2018 Methods Exam 2. So this question is an 11 marker, it's 4 pages, so I have 2 double-sided sheets printed out right here, so there's quite a bit of stuff in there. But the question overall isn't too bad. The setup is just this bridge right here that we have as a straight line at y equals 5, and then we have these 3 arches. And if you look at these equations right here that describe the arches, they're basically the same thing, just translated over. So the first page we have state the value of a, we can figure that out quite easily, and we have to describe the transformations between 2 of the arches. And if you look on the next page right here, this is an integration question. So it's just finding this area right here, that's not too bad to do. And then on the next page, we have a bit of a different bridge, but these arches, if we take a read right here, these arches are the same, it's just the bridge is a little bit different. We have to find the gradient of the bridge, and we have to work out what these points are right here as well. And the final part of this question is finding the distance. So we have point P, then we also have this point Q right here that we have to find somehow, and we have to find the distance PQ. So interesting question, it's not too bad, and we can use the programs to help us out quite a bit as well, which is quite nice. So as always, let's start the timer and see how fast we can answer this question. So first of all, I've noticed that since these 3 bridges are the same, it really doesn't matter which one of these we choose. But there is, on this next part right here, on this next page, we do use this second arch right here quite a lot in order to find out this length. So it would be a wise idea to define our function h2. So we're going to go to menu 1.1, define h2 of, what is it, x to be equal to 5 times the sine of x minus 40 times pi, and then we have this divide by 30 like so. Okay, so we have our h2 to find, that's good. We also have to set the value of a, where a is a real number, so a is right over here on our h3. And notice these are just translations of each other. So arch 1 we have x minus 5, then we have x minus 40, x minus a. Well, for this first arch, the reason why it's 5 is because it kind of starts right here. We have a translation to the right by 5, then we have a translation to the right by 40. That's why arch 2 starts here, and arch 3 starts at 75. So that means this a value has to be 75. So a is 75, and describe the transformation that maps y of h2 to y of h3. Well, we jump from 40 to 75, so that's a translation 35 units to the right. So we can write translation of 35 units in the positive x direction. And that's enough to get June the mark. So next page right here, we have to find the area now. So this is actually not too bad to do. If you take a look at this, this is basically this rectangle area, and we take off each of these 3 areas. So if we write it out a little bit, the area is equal to the rectangle area. We have the length, which is 110, times the height, which is 5, and then we have to subtract off 3 of the area of each of these arches right here. But we have the area of the arch 2 defined. It's just the integral from 40 to 70 of h2 of x dx. Of course, you can do the same thing for arch 1. It would just be from 5 to 35, but I'm using h2 because it's a little bit more efficient that way, because we're using h2 a lot, so in dx. And well, we can show a bit more working on this is 550. Then you have you can do shift plus to get your integral from 40 to 70 of h2 of x, like so, and then dx. You can evaluate, that's 300 pi, so you have minus 3 times 300 over pi, and then you can do your final step of working out, so that's 550 minus 3 times that value. Oops, shouldn't put a 0 there. And then this is to the nearest square meter, so let's approximate 263 rounded up, it's 264 meters squared, like so. Right, and next page, we have to state the gradient of the second bridge. So this bridge has some kind of inclination to it. We know the angle is pi over 90, and if you don't know, there's this relationship between angle and gradient, namely that the tangent of the gradient of some gradient m is equal to the angle. So if we want the gradient, we just take the inverse tangent of the angle, which in this case is pi over 90. So I guess we can just write inverse tangent of pi over 90. And if we evaluate that on our CAS, go to trig right here, inverse tangent of pi over 90. Let's approximate that. It's going to give us 0.035, correct 3 decimal places. Alright, so the next part here, we have to find point P, which is on arch 5. So this arch 5 right here, we have to find the coordinate of this point. And we know that the tangent to arch 5 at point P, so if we construct some kind of tangent line right here, has the same gradient as the second bridge. So it has this gradient that we have over here. And there's a nice program that kind of does that for us, the Solve Gradient program. So if you go to your catalog here, go to differential calculus and go down to solve grad, all we can do is we can put in our functions, say h2, was that h2? Yes, h2 of x, and then we tell it what variable, which is x, and then we tell it the gradient, so 0.035, so 0.035 like so, enter. And then it's going to ask us for a domain. We actually do want a domain because notice this is a trig function. If we don't add a domain, then it's going to give us infinitely many points. So let's chuck a domain in, and we're going to go from 40 to 70. So lower bound to 40, upper bound to 70. And it's going to give us this coordinate right here. So we can literally just write down that coordinate, 54.36, 4.99. This is the 2 decimal places. But of course it's 2 marks, so I have to show a little bit more working out. But that's not too bad to do, because if you take a look up here, then the program kind of tells you what it does. So we can have h2 prime of x is equal to minus pi over 6 sine of pi x over 30 plus pi over 6. And we want to solve that for 0.035. So just write something just so they know that you know what you're doing. So this implies that x equals 54.36. So h2 is equal to 4.99. That should be enough to get you the 2 marks. So we found point P, which is nice, and now we just need to find point Q right here, because we need to find this distance PQ. So I guess step 1 of this question is to find Q. And how can we find Q? Well, notice that Q is just this intersection between the normal at point P as well as this bridge. So we know the bridge equation. So bridge, that's like how you spell bridge of bridge. The equation we can construct quite easily because we know the y-intercept and the gradient right here. So y-intercept is 5, gradient is 0.035. So obviously that's going to be y is equal to 0.035x plus 5. And how about the normal? So the normal line, how do we find that? Well, that's not too bad to do. Just use, for example, function lines or something on that program. So go to var function lines and then put in your h2 of x, comma, your variable x, and tell it what point you want to find the normal line at. So of course that's going to be 54.36, like so. And it's going to tell you the normal line right here. Let's see what it is. So normal line, that's going to be y equals 155. 5.22 minus 28.5179x. So that's the normal line right there. And now to find the intersection of these 2 points, so we have the bridge, we have the normal line. Let's use the intersect program to find the intersection point. So if we go to intersect right here, and we have to put in our 2 functions. So our first function is 0.035x plus 5. And then our second function is this normal line right here. If you don't want to type it in, then you can go into the function lines program and kind of hold shift and scroll across to highlight it, enter it in, like so. And with respect to your variable x, add a domain. Don't really need a domain. It's going to give you your intersection point. So I guess the Q is the corner Q is 54.2929, 6.9, like so. And so we need to find the distance, and nicely there's a program that does that for you, which is linear info. So if you go down to methods miscellaneous, linear info, you can literally go into your program, put in these 2 points, enter them in. So that was from the intersection. We also had one from the solve gradients. So enter that in, enter, and it's going to tell you the distance, which is 1.9. So distance 1.9, and it's to 2 decimal places, so 1.91, and it's 3 marks, so you can show a little bit more working on it if you want. But yeah, that's your distance right there. So that's your answer. So I guess that's 11 marks in 10 minutes. That's under 1 mark per minute pace, which is pretty good for an exam. Of course, I did have to explain quite a bit of stuff, so it would have been a little bit faster as always. But yeah, that's it for this question. Hope you guys enjoyed this video, and I'll see everybody next time.